Hi, everybody. Good morning. Today is Wednesday, February 7th. So today we will continue to finish 7.3 and 7.4. And then right now we're slightly behind the schedule, but it's okay. But I want to give you more time to study for the exam one, especially last class. 6 students missed the class, and this unit circle worksheets, only 7 of you get them all right, and we have 18 students in this class. So I think you probably need more time to really work hard memorizing. I teach you the pattern, right? So you follow the pattern and then help you to memorize them. So I decided to move our exam one to the Monday, February 19th. So it was scheduled on the Wednesday, Valentine's Day. So I moved the next Monday. Then you have more time to study. Okay, everybody? So please work hard. Okay, so if you didn't get perfect scores on your unit circle worksheets, please come to see me. Today, I will be in my office from 11 to 1:50. And tomorrow, I will be in my office from 10 to 1:50 and also 3:20 to 5 p.m. Okay? So if you don't get them all right. Hi, what's your name? Okay, here's your worksheet. Yes, if you don't get them all right, please come to my office and do it again. All right. So let's remind you one more time. We find the patterns. Okay, so patterns. Instead of how do we memorize all these numbers, right? We find the patterns. You fill out the angles with 30 degree and 45 degree, right? So you start with this one. This one is 30 degree. And then you add 30 degree, add 30 degree, add 30 degree until you get to the full unit circle. This is how you fill out the 30 degree, multiple of 30 degree. And then you fill out multiple of 45 degree. You know, 45 is where? Right here. Yes, everybody? It's right here. So that is 45 degrees. Okay? And then we add multiple of 45 degrees. I think I'm missing one line here. Okay. Yeah, your picture has a line there. Okay. So after you fill out the degree, and then you fill out the radian. So this symbol is where the place you fill with the degree. And that symbol is the place you fill with the radian. Okay? Your radian, 30 degree corresponds to pi over 6. Right? So then you add multiple of pi over 6 until you get to the full circle. And 45 degree is pi over what? 4. So you add multiple of pi over 4 until you get to the full circle. And then how do we figure out the coordinates? Remember the coordinate, x coordinate is cosine theta, y coordinate is sine theta. And for example, 30 degree. This is 30 degree. Cosine 30 degree is what? Cosine adjacent over hypotenuse, right? So that's why here is root 3 over 2, and then sine 30 degree is opposite over hypotenuse. That's why this is 1/2. Okay? So if you don't get perfect scores on the unit circle, or if you haven't taken it, come to see me. Okay, so you don't have to be completely ready and then come to see me. If you have trouble memorizing them, I can go through the rules with you again. Okay, and then I can guide you to do all of this step by step. Okay, so come to my office. I will help you. Clear, everybody? Mm-hmm. So if you haven't, take the unit circle worksheet. Please come to see me. All right. So our exam postpones to Monday, February 19th. So you have more time. Okay, so let's continue. Our worksheets, class worksheets, 7.3, 7.4. Okay, let's close this and this one. Okay. All right. So, see. So last time we talked about reference angle. Do you still remember this table? We learned the pattern. What's the pattern? One thing, square root of n over 2. And you plug the n equals 0, 1, 2, 3, 4. In that case, you can fill out the values in the first row. Yes? And the second row is the cofunction. Same number, reverse the order. Yes? Everybody? And then the third row, tangent is sine over cosine. So using the first row number over the second row number. Right, everybody? And the cotangent, same number as the tangent, but reverse order. Right? Mm-hmm. And secant is 1 over cosine. And where is the cosine? The second row. Right, everybody? So 1 over that. So flip the numerator and denominator. Okay, everybody? And the cosecant, same values as the secant, but reverse the order. So this table is very important. So make sure you practice memorizing the values. And I would say learn the pattern. Then you can write down all the numbers. Okay, so find the pattern. Okay, and then last time we draw the reference angle. So our angle T could be in 1, 2, 3, 4 quadrants. And the reference angle is the angle made with the terminal side of the angle and the x-axis. So the reference angle is always a acute angle between 0 and 90 degrees. Right, everybody? So you draw the picture, then you can actually see the relation. Like in quarter 1, the T and T prime, they're the same. Right, the angle made with the x-axis is the same as the T. But quarter 2, oh, that's my T. Then the angle made with the x-axis is now this one, right? And you can see that. Okay, attendance. Thank you. Okay, so you can see this angle plus this angle is pi, right? And quarter 3, that's the T, but then the T prime is the angle made with the x-axis. This is T prime. From the picture, you can see our T is pi plus T prime, right? So draw the picture, then you can see the relation. How about quarter 4? You see T plus T prime is the full circle, 2 pi. Okay, everybody? So draw the picture, then we can find the relation. So math is finding the pattern. Okay, everything has pattern. So last time we did number 17 and 19. Today we're gonna continue. Okay, so after we find the reference angle, how do we find the trig functions? Okay, so look at this, 150 degree. So 150 degree, let's draw Okay. Draw the picture. 150 degree. Which quadrant it lies in? 2. Quadrant 2. So draw a picture. Quadrant 2. So this is 150 degree. We're in quadrant 2. Yes, everybody? Now, can you see the reference angle? The reference angle is the angle made with the terminal side and the x-axis. So, what is T prime? Yes, is so T prime plus 150 degree is 180 degree. So T prime plus 150 degree is 180 degree. Yes, everybody? And so T prime is then 180 degree minus 150 degree, which is 30 degree. Okay, everybody? By the way, if you come in late or you miss some class, make sure you watch the class recording. Because every day we learn something new and you're gonna memorize some formula. And when I also teach you the rule, the pattern, how to memorize the formula. So please watch the recording, and if you have questions, come to see me. Okay, everybody? So that's the T prime. Now, what is cosine 150 and sine 150? Okay, the rule is that the cosine 150 is equals to plus or minus cosine of the reference angle. Okay, that's the rule. So if you have like trig function of the t is the angle is either plus or minus a trig function of the reference angle. And then this plus or minus, it depends on the trig function and the quadrants. Exactly. So like here, cosine. So cosine in terms of x, y, r is what? X over r. And we are in quadrant 2. Okay? So in quadrant 2, your x is positive or negative? Negative. And your r is always positive. Right, everybody? So the whole thing, x over r is going to be, you have the numerator negative, denominator positive. So the whole thing is negative. So therefore, the cosine here is negative. We pick the minus. So that's the rule, okay? If your angle is not in the first quadrant, thank you, then we look at the reference angle. Okay? We look at the reference angle. We draw the picture, find the reference angle, and then it's either plus or minus the trig function of the reference angle. The plus or minus, you need to look at the quadrant and express it in terms of x, y, r. Then you can know it. Okay? So now, so we know the answer is negative. What's cosine 30 degrees? Okay, now you're gonna look at this table. What's cosine 30 degrees? Square root of 3 over 2. Yes, so that is square root of 3 over 2. Is that okay, everybody? Now, how about sine 150 degrees? This is plus or minus sine of the reference angle, 30 degrees. But plus or minus, what is sine in terms of x, y, r? Y over r. Yeah, your your r is always positive, right, everybody? So that's why y over r. So this is positive, so the whole thing is positive. Is that okay to draw something like that? I mean, the whole thing is also positive. So we take the positive. Now this is positive sine 30 degrees. Look at your table. What is that? 1/2. Thank you. So this is 1/2. Is that clear, everybody? Mm-hmm. Right. Okay. So yeah, we record our class. If you missed some class, and please watch the recording. And if you have questions, come to see me. And I already postponed the exam one from the Valentine's Day to the Monday, so you can catch up. Okay, so if you haven't do your homework and missed some recordings, please catch up and come to see me. All right. Okay, so let's continue. Okay, using the reference angle, find all 6 trig functions of negative 5 pi over 6. So let's draw the picture. Negative, what does that mean? It goes clockwise instead of counterclockwise, right, everybody? And 5 pi over 6, you see, is less than pi, right? So pi, if you go pi, negative pi is right here. But negative 5 pi over 6 is less than pi, so you don't rotate that much. Then the angle is right here. So this is negative 5 pi over 6. Is that okay, everybody? Mm-hmm. Okay, so the negative, because this is clockwise, okay? But if you just look at the measure of this angle, it's a obtuse angle, and it's 5 pi over 6, if we don't want to count the direction. Okay, everybody? And how about this angle? Yeah, this is the reference angle, T prime. Now look at the picture. What is T prime? If this angle is 5 pi over 6, what's T prime? Can you look at the picture? The T prime plus this 5 pi over 6 equals pi. Yeah, from the picture, right? And we don't want to count the minus because we just want to look at the measure of the angle, not including the direction. Okay? So what is T prime? Pi. 5 pi over 6, which is so common denominator is 6, right? Pi is like 6 pi minus 5 pi is pi over 6. So the reference angle is pi over 6. And we want to find all 6 trig functions. Okay, let's do that. So you want to write tiny. Okay, so sine negative 5 pi over 6 is going to be plus or minus sine of the reference angle. And sine is what? Y over r. In quadrant 3, your y is positive or negative? Negative. Your r is positive. So the whole thing is negative. So we pick the negative. Now, what is sine pi over 6? Look at your table. Sine pi over 6 is 1/2. See, that's why you need the table. So in the exam, I will give you a blank worksheet. So you can fill out the values of the table, and then you can work on the problems. Okay, so therefore we get negative 1/2. That's the sign. Next, cosine. So cosine negative 5 pi over 6 is plus or minus cosine pi over 6. Okay, cosine is what over what? X over r, right? But x is positive or negative? Negative. And r is positive. So the whole thing is negative. So we pick the negative. And what is cosine pi over 6? Yeah, square root of 3 over 2. Is that okay, everybody? Mm-hmm. Now, tangent. Tangent is plus or minus tangent pi over 6. But what's tangent in terms of x, y, r? What's tangent in terms of x, y, r? Y over x. Is everybody okay? Tangent is opposite over adjacent. So, T-O-A. Opposite over adjacent. Opposite is y. Remember the picture? Adjacent is x. So y over x. Y is positive or negative? X is positive, negative. Negative. Oh, you see the whole thing is positive. So we pick the positive. Yeah, everybody? Okay. So positive. What's tangent pi over 6? Look at your table. 1 over square root of 3. Yes, very good. Right, everybody? Once we figure out the sine, cosine, tangent, what's the cotangent? Reciprocal. Yeah, square root of 3. And then the secant. Negative 2 over root 3. Bless you. And the cosecant. Negative 2. Yes, once we figure out those three, these three we just flip it. Everybody? All right. And so that is number 20. Okay? All right. Now continue. Find the coordinate of the point on the unit circle at the angle of 7 pi over 6. Okay. 7 pi over 6 is in which quadrant? 3. Yes. So this is in quadrant 3. And you can see this is what? This is like pi plus 6 pi over 6. So this is like pi over 6 plus pi. So, and you can see pi over 6. So like this angle is pi over 6, right? And this angle is pi. Therefore, do you see this angle? It's actually called terminal of negative 5 pi over 6. They're called terminal angles. So we have like the same picture here. Find the coordinates on the unit circle. Again, unit circle practice, right? Coordinate x, y is x is cosine theta, y is sine theta. So it's cosine 7 pi over 6 and sine of 7 pi over 6. Is that okay, everybody? Yeah, that's the unit circle, right? X, Y. X is the cosine theta. Y is sine theta, where your R is 1. Okay? And now, because this angle is coterminal to our previous problem, right? So our cosine will be, yeah, the same cosine value here. Is that okay, everybody? Coterminal angles. Same all six strict functions. So we get negative square root of 3 over 2. How about the sine? Yes, negative 1/2. So that is the coordinates. Okay? By the way, if you missed last class I gave everybody a unit circle practice, and 7 of the students get perfect. So if you didn't take it or you didn't get perfect, please come to see me. Today I will be in my office from 11 to 1:50. Tomorrow I will be in my office from 10 to 1:50 and 3:20 to 5. If you're not ready, if you don't remember those, you can still come to see me because I will teach you the pattern, how to remember those values. Okay, so come to see me. So yeah, we finished number 21. Any questions? So far so good, everybody? Okay. So yeah, you can practice more, like this problem, or this problem. You figure out the reference angle, and now you can find the values of all 6 trig functions. Okay, next topic. Negative angle identity. Okay, so negative angle identity. Let's draw some pictures. So we have this the x-axis, that's the y-axis. That's 0. Okay, so let's draw this picture, and let's say this is t, and this is the coordinate x, y. So x, y means our horizontal distance is x, and our vertical distance is y. Is that okay, everybody? Mm-hmm. Okay, now if this is t, what is negative t? Negative t is going clockwise direction. So this is negative t. Is that okay, everybody? Yeah. T, positive t means go counterclockwise directions. Negative t means go clockwise directions. Now compare this point. Our x value. Do you see they have the same x values? But how about the y values? It's negative. Exactly. So that is x negative y. So draw this picture. You can see the relation. Okay. Now, sine. Okay. Sine is what? X, y, r, what over what? Sine is, yeah, y over r. Okay? But the sine negative t, your y is negative. Okay, everybody? So for sine negative t, I actually get negative y over r. Therefore, negative y over r is negative y over r. So sine minus t is negative sine t. Is that okay, everybody? Mm-hmm. Yes. How about, where's cosine? Okay, cosine is here. What is cosine? X over r. So cosine is x over r. But look at the cosine negative t. It's also x over r. Right, everybody? Uh-huh. So this is also x over r. Okay, now tangent. What is tangent? T. Y over X. How about tangent negative T? Now my Y is negative Y. Yes, everybody? We get negative Y over X. Therefore, the tangent negative Y over X, you can put the negative in front. So tangent negative T is negative tangent T. Sine negative T is negative sine T. And cosecant negative T is cosine T. Okay, everybody? And you know the reciprocal follow the same rule. If sine still have the negative, then the cosecant you still have the negative. If tangent still have the negative, cotangent still have the negative. And then the cosine does not have the negative, and the cosecant does not have the negative. Is that okay, everybody? Mm-hmm. So this property is related to even function and odd function. Have you learned like even function and odd function before in algebra? Maybe you did, but you forgot. Okay, so a function is even function if f of negative x is f of x. For example, even function x squared. So even function, this is x, and this is minus x. Do you see f of x is equal to f of minus x? They have the same one. This is even function. And they are symmetric with respect to the y-axis. Yeah, everybody? That's even function, symmetric with respect to the y-axis. And f is a function if f of minus x is negative f of x. Can you give me an example of a function? X cube. Yeah, everybody? And therefore, like for x cubed, if x is here, that's the y. And if minus x here, you get minus y. So therefore, for the f function, the graph is symmetric with respect to the origin. What does that mean? Okay, symmetric with respect to the y-axis is like the y-axis is like a mirror, right? You have mirror image. Yeah? And symmetric with respect to the origin means any point here, you rotate 180 degrees about the origin, that the new point is still on the graph. So this is symmetric with respect to the origin. Is that okay, everybody? Now, you look at all 6 trig functions. So we get the odd function. They are sine, they are cosecant, and tangent, cotangent. An even function where the minus sign disappear, we have cosine and secant. Okay, you just imagine cosine and secant. They're so hungry they eat the minus sign. So it disappeared. Okay? Sine, cosecant, tangent, cotangent, they don't eat the minus sign. But cosine and secant so hungry they eat the minus sign. Is that okay, everybody? So this is the negative angle identities. All right. Now, given tangent t is 15, what is tangent negative t? Tangent negative t? Does tangent eat the negative sign? No, it does not eat the negative sign. So it equals to minus tangent t. What is minus tangent t? Negative 15. Yeah, that's it. Okay? So you relate the negative angles and the positive angles. Does the trig function eat the negative sign? Mm-hmm. Okay. How about example 2? So everybody do example 2. Is the answer. Okay, so what is your answer? Sine negative t. Sine does not eat the negative sign. So we have negative. Sine t is square root of 3 over 2. Okay? So remember only 2 functions. They are very hungry. They are what? Cosine and secant. They're so hungry they eat the minus sign. Okay? So what's your answer for example 3? Ah, yes. So secant negative t is secant t, but your secant t could be negative. Okay, everybody. So here when I say the minus sign, eat it or not, I'm just comparing with the sine t or secant t. The secant t itself could be negative. Okay, everybody. Yeah, that's why here secant minus t is secant t. But the secant t itself could be negative. Okay, everybody? So that is the negative angle. Now let's do some application. The amount of sunlight in a certain city can be modeled by the function h equals 16 cosine 1 over 500d, where h represents the hours of sunlight and d is the days of the year. Use the equation to find how many hours of sunlight there are on September 24th, the 267th day of the year. So this problem we just plug in, right? So 16 cosine 1 over 500. Now we plug in the d is, 267. So plug this in your calculator. Use degree or radian mode? Radian. So everybody take out your calculator, plug this in your calculator. What do you get? Use radian. Why? Because we don't have a degree symbol. Yes, you have to see the little
How many
circle.
decimal places?
How many? Okay, 3. Let's use 3 decimal places. Everybody practice using. Okay. What is your answer? Thank you. So, and yeah, so this is the answer. Oh, 772. Thank you. 772. Okay. So that is the answer. Okay, everybody? So this is everything we learned in chapter 7. Yes. So this is what your exam 1 is going to be about. So chapter 7. And I'm going to give you this blank formula sheet. So I will give you in the exam. So you can practice filling those out. So in the exam, you can fill out the sheet first, and then you can continue to work on the exams. So I think this formula, blank formula sheet, gives you an idea like what formula you need for the exam. Mhm. And now let's review them all together. Okay. And I will ask you one by one to tell me the answer. Thank you. Okay. All right. So this is examples. Okay, chapter 7. All right. So let's practice together. Again, our class is like a family. So don't be afraid of making mistakes because sometimes I make mistakes too. Okay. So we just learn from it. Okay. So yeah. All right. So let me just ask you one by one. Okay. So we start with this right angle triangle, and we want to fill with opposite, adjacent, and hypotenuse. Okay, Sierra, what is sine? Yes, opposite over hypotenuse. Uh, Erica, what's cosine? Yes. Right, everybody, we practiced this before. Let me also practice your name. Madison, what is tangent? Yes. Cotangent, Zach. Yes. Secant, Jeremy. Good. Yes, it's the reciprocal of cosine. And Sophie, cosecant. Yes. See, that's the reciprocal of sine. Did everybody finish this part? Okay. And the next, you need the on the circle, right? Sine theta. Emily. Y over R. Good. Cosine theta. Is it math one? Oh, okay. What is that? Yes, S over R. Tangent. Verticus. X over Y. Opposite. Well, who's opposite? Tangent is Y over X. Opposite over adjacent. Okay. Cotangent, Oscar. Yeah, X over Y. Okay, secant, Kevin. Yeah, R over X. One, cosecant. Yes. So everybody finish that part? Mm-hmm. Okay. See, practice a lot again until we get them. Okay. Now we have this hexagon. What is the diagonal formula? Kane. Sine theta. And make sure you put the angle theta times cosecant theta is 1. Next one, Michael. Yes. Next one. Okay, let me see. Next one we have even. What is the remaining diagonal? Yes. So cosine theta times secant theta is 1. And then let's look at the upside down triangle. The first triangle, Cecilia. Yeah, sine theta squared plus cosine theta squared is 1. And then Sierra. Yes, very good. Erica.
Cotangent
Theta squared plus 1 is?
cosecant theta squared.
Yes. Is that okay, everybody? Mm-hmm. Right. So we understand the pattern, help us to remember them. Okay. The next one, I asked the whole class. Do you remember the length of sector? S equals theta r. Theta times r. This is actually how we define radius. It's the ratio of the length of the sector over the radius. Okay, everybody? Mm-hmm. Area of the sector. So we have a sector like this, right? And let's say this is theta, this is r. S is the length of the sector. Now area is, see, this is area. What's the area? Anyone remember? 1/2 theta times r squared. Okay, if you don't remember, write it down. 1/2 theta times r squared. That's why when you plug in theta is 2 pi, you get the 2 cancel, pi r squared is exactly the area of the circle. You know the area of circle is pi r squared, right? Yes? Mm-hmm. Okay. And then here we have the angular speed and linear speed. Angular speed is the number of revolution times like 2 pi over the time. Okay. Let me see. Yeah, if it says that, okay, it goes like 3 revolutions over 2 minutes. So then you use 3 revolutions times 2 pi and then over 3 minutes. Okay, everybody? And then V, the linear speed is the angular speed times R. Is that okay, everybody? Mm-hmm. All right. So let's continue. Oh, okay. We ran out of time. So let's continue on Friday. So Friday, you will work on the practice exams. So I hope you can print out the practice exam before Friday. So go to the bottom of our website. The practice exam 1, print out, and then you can work on it in class. And I have the solution. Okay? Have a nice day.